Good day, ladies and gentlemen. So I am here today to share to you another discovery uh, that I've seen from one of my clients in my tutorial. So this one is exclusively done that I have a client from Africa. So here's the thing that I want to share to all of you, and I hope that you would get an idea on how to solve this. And the problem looks like this. So you have a couple of numbers with exponents like this. Which goes like this. So you have 5 raised to 1 half times 20 raised to 1 half divided by 64 raised to 1 half times 3 raised to 0 times 5 squared. So basically speaking, this is just only an application for exponents. And a little more challenging, we have fractional exponents. Well, at some parts, this could be originally using radicals. But since it's already in exponential form, this is easy to solve. Well, the plot twist to this problem is you cannot use any table or calculator or anything, just your know-how in algebra. So how can we solve this? Okay, let's take out all of the distractions first, like this 3 raised to 0. So this one is actually negligible because this is equal to 1. So we can take this out. Now, 20 has a factor of 4 and 5. So we can split that up. So you will have 5 raised to 1 half times, you have 4 times 5. That is raised to 1 half. Oh, I almost forgot this should be negative. My bad. Okay, all over. This 64 can be changed to 4 cubed. That again raised to 1 half. And then times we still have 5 squared. We'll get to that. Okay, so this exponent here will be distributed to both 4 and 5. Well, as part of the loss of exponents. So, you will have 5 raised to negative 1 half times 4 raised to 1 half times 5 raised to 1 half. Now, this one is power of a power, so we can multiply these two. So you will have 4 raised to 3 over 2. And then we still have 5 squared. Okay? Now, as you may notice, this and this are all the same base. They're all 5s. But it is best that we go to the numerator first before we add it to the denominator. But you'll see something interesting here. Since we multiply with the same base, we add the exponents, right? So you will have 5 raised to negative 1 half plus 1 half times 4 raised to 1 half. Then we still have a 4 raised to 3 halves times 5 squared. Now you may notice that this are opposite. And if you add this, it will result to 0. And since this is raised to 0, again, this is non-negligible. This is now a 1. Now we're left over with 4 raised to 1 half all over 4 raised to 3 halves times 5 squared. We're not done yet because we still have another common base here, which is 4, and we have these exponents. Now, Apparently, the one at the bottom is bigger than that of the numerator. So, the best way to do there is we do the operations at the denominator instead. So that the bigger exponent we go before the smaller exponent. Because of course, who would get an exponent that is negative? Of course, no one, right? So, we will go at the bottom. So, simplifying this, that will be 1 over, this is now 4, this is now 3 halves minus 1 half multiplied by 5 squared. And we already know that since they have the same denominator, which makes them similar fractions, we can now directly subtract the numerator. So with 3 minus 1, you'll have 2. So you have 1 over 4 raised to 2 over 2 times 5 squared. But we know for the fact that 2 over 2 is equal to 1, right? So if this is equal to 1, this is just 4. And we can now simplify 5 squared as 25. So you will have 1 over 4 times 25, to which results 2, 1 over 100. From a complicated expression like this, we ended up with a simple fraction as this. Share this video to others for those who are interested in these kinds of problems. Till then, this is Mega Vinx, signing off.